All right, welcome back. We just got done factoring polynomials, and so now the next thing that we're going to do is we're going to start graphing them. Before we get into the whole step-by-step way of going through and graphing these things, we want to talk about general shapes. And we touched on this back when we talked about general shapes of graphs, and then also when we talked about graphing things last week, that, what the general shapes are, what happens when you have got roots with multiplicities bigger than 1, things like that. So anyway, first of all, let's make a chart. We're going to have to talk about degree, okay, and then an example, and then what the shape will look like. Example function, and then the graph. Suppose I could type that out. Anyway, so degree 1. So you'd have, let's say, like f of x is equal to 2x. Maybe even, let's say, like plus 3. So in that case, you're going to end up having just a line. Now notice, well, we'll get to that. Degree 2 is quadratic. So what shape is that going to be? You're right, a parabola. So then you're going to get something that looks like this. Degree 3 is cubic. And if you remember from before, 6x squared minus 7x plus 2 or something like that. You're going to get this shape that kind of gets like this. 4, let's say x to the 4th minus 9x cubed minus 7. And again, for this one, so let me slide this down a little bit, sorry. Oops. Okay, this one's going to look something like that. Okay. A couple of general thoughts here. Okay. The degree number in general equals the number of directions. If your multiplicity, if all the multiplicities equal 1. Okay, so like right here, 4th degree, we're going up 1 direction, 2 directions, 3 directions, 4. Okay. Also notice, and we talked about this last week, but just to reiterate, even degrees start and end in the same direction. Okay, so either they're gonna come from the top and finish going up, or they're going to come from the bottom and they're going to finish going down the bottom. So odd degrees start and end in different directions. And so it could start up as if the leading coefficient is positive, it's going to look like this. If the leading coefficient is negative, it's going to look like that. Okay, and that's the last little bit here. Your leading coefficient essentially acts like your slope. Okay, so if it's positive, you're going to end up like this. If it's an even degree, or it's going to end up like this. If it's an odd degree, if it's negative, then it's going to start from the bottom and end on the bottom on even degrees. And it's going to go downhill if it's odd. All right, so that's the nuts and bolts of that. So I know this is kind of different. I'm going to give you the 4 steps first. 4 steps to graphing polynomials. Step number 1, you have to worry about what's the general shape. Okay, what we just did. The reason why you need to do that is so that that way you can decide, well, you kind of have an idea going in what it should look like. So if your graph doesn't look like that, then you obviously have made a mistake. Secondly, you need to go through and find the zeros of the function. So either they'll get some of the problems that you'll have, they'll give it to you in factored form so you can focus on the graphing. Other problems they're going to give you, it'll be, you're going to have to factor it out like what we did in section 3.3, where you factor polynomials. So you find the list of possibles, et cetera, and we'll go through an example of that. The third step is you're going to find the values of points in between the zeros. That's so that you can get a nice shape to your graph, and so it's accurate. So you're not just kind of blindly running, you're doing a really rough sketch. And then lastly, you're going to go through and actually graph everything. Okay, so the big ideas here are going to be general shape, find the zeros, find the points in between, and then graph. So the first one that we're going to do is very basic. It's already in factored form. So 1, general shape. Now notice if I multiplied this out, I would get y equals x to the third. So that means that we know that it's going to look roughly like this. Okay, it's going to start low and high. We're going to have 3 direction changes. And in the next one, we're talking about what happens when you've got multiplicities of other than 1. 2, your zeros, since it's in factored form, it's pretty easy to find. You're just going to pull them off here. You've got 1, and -2 would make that whole function equal to 0, and so would -3. Now, for point 3, you're going to find the points in between. And I'm going to make a little t-chart here. Now, the nice thing is once you have it in factored form, life gets a little bit easier in terms of dealing with finding the numbers in between. Now, in this case, well, hold on. I'm sorry. So we know that 1 goes to 0, -2 goes to 0, -3 goes to 0. So now we're going to have to find other ones. So in this case, let's find a number that's bigger than 1. So maybe let's say 3. If I plug in a 3 up into this function up here factored, 3 minus 1 is 2. 3 plus 2 is 5. And then 3 plus 3 is 6. So in this case, I've got a number of 120. So it's going to be way off my graph. Pick a number like 0 here in between 1 and -2. So if I do that, I'm going to get -1 times 2 times, times 3. And that's going to give me a -6. Sorry, couldn't read my own handwriting there for a second. All right, so we've got 0 minus 1 is -1, 0 plus 2 is 2, 0 plus 3 is 3, so that's going to give me a -6. Now for here, between the two zeros, you could go like 2.5. I'm going to go ahead and do it just for sake of argument. You know it's just going to be a small bump. It should be positive because these areas, since all the multiplicities are 1, you should be alternating from negative to positive, negative, positive. But so if I plug in -0.5, 2.5, I'm going to get a -3.5. Then I'm going to get a -1/2, and then a +1/2. So that is going to be approximately, let's see, what is that, 13/2? So that's going to be a -13/8. So right around 1, almost actually -2. And then just for grins, I'm going to go one a little bit past here. So I'm going to go -4. And so -4 would give me -5, -2, and then -1. And then that would give me, what, -10. And this should be positive. My apologies. Okay. So now, step 4 is going to graph this. So make sure you set up your axes. And then go across. Now most of our numbers are small enough. This 120 I'm not going to worry about actually plotting. So I'm just going to go ahead and do a standard 1 to 1 to 1 to 1. So 1, 1, -1, -1 graph. And then you're going to plot these. So -4, I'm going to go down to -10. So 2, 4, 6, 8, a little bit lower, right about there. -3 is a 0. -2 is going to go up a little bit bigger than 1. So I said almost 2. It's actually about 1.5. Come back down to at -2, to, oops, too far. This is 2.5. And then get there. And then at 0, I'm going to go down to -6. At 1, I'm going to come back up to 0, and then by 3, I'm already way up here. So then at this point, now you're going to do your rough graph. Go up and come down, and this, of course, is the hard part, doing this on a tablet. Whoa, that was bad. My apologies. I know you are expecting to see better from me. Wow, this is a bad idea. Graphing polynomials with a slate is not the easiest thing. My apologies. You get the general idea, though. It does meet our general shape, and away we go. Okay. So again, general shape, we found the zeros, we found points, and we plotted out the points and we connected them. Pretty standard graphing here.